All right, I want to show us another way to think about equivalent fractions. I'm still going to use the model of 1/2 and then our 6 eventually. So here you can see our tape diagram that I drew. I have the tape diagram and I shaded in one of the halves to represent my fraction 1/2. Now what I'm going to do is with a different color, I'm going to take my purple and I'm going to break this fraction up even more. I'm going to break it up so that I'm turning my whole, which is represented by the full tape diagram, into sixths. Now I can do that by thinking about if I have 2 halves and I want to create 6, how many parts need to be in each of the halves? I need to make sure that each have 3 parts because ultimately I know 2 times 3 equals 6. So I'm going to break them up a bit more. And now you can see how I turned the 1 whole into 1/2 at first, and then I broke it down into the sixths even more. Now I'm still just focusing on this shaded part because that's never changed. I never changed the fact that I'm representing only 1/2 of this tape diagram, except I did change how many equal parts I broke it into. So my denominator is no longer going to be a 2. It is going to be a 6 because I broke it into 1, 2, 3, 4, 5, 6 equal parts for the whole. How many sixths, though, are being represented is the question. I see 1/6 here. So 1/6 plus 1/6 plus 1/6. We know when we add these fractions together, what this will turn into is that 1/2 is equal to 3/6. Let's think about if those numbers make sense in our heads, because I know that half of 2 is 1, and I'm talking about halves. Is half of 6 3? Yeah, so these numbers should also make sense in our heads as well. All right, between this video and the other one, I want you guys to try the problem set on your own. If you have any questions, please let me know.